Good morning, everyone. I thought I'd spend a bit of time this morning just reflecting on the quantitative and qualitative wonderland I've been wandering through, or we've all been wandering through over the last couple of weeks. And the question, which research methodology do you choose? And what drives a researcher to be quantitative or qualitative? And I suspect it boils down to something quite simple, and that is what they're good at, what they know. And that's sort of obvious, isn't it? You use what you know, and it might be because that's the training you've had, your supervisor, that may have been their methodology, or it may just be, you choose a qualitative flavour because you don't like statistics. You're not good at statistics, you think. And been interesting piece of research, I think, to see if you could find a correlation between sort of mathematical ability or how much you like mathematics or statistics and your research methodology. Not that you actually get any participants to do that research, I suspect. But I mean, there is something attractive, something nice about qualitative design, because you have numbers, and when you've got those numbers you can manipulate them and get nice equations and make predictions, and that's sort of attractive, I guess. People like that sort of predictability. But what are these numbers? What we talk about, we get numbers in our equations, and we get numbers, we plug into SPSS. These numbers really, they're meant to be a representation of a characteristic in a population, or the sample we've got of the population. And most of the time, probably all of this time, these numbers a measure or description of the central tendency of this characteristic, and that can be the arithmetic mean usually, and that's what it is. It's a central tendency, whether it's level of stress or obesity in a sample, or the heights in a classroom, or the weights in a classroom. And if you get a population, a sample, and you measure the different heights, some will be this height, some will be this height, and there'll be variation in the heights, but you can probably find a central tendency, which is the mean, and there'll be some above, some below it. And if you sort of add those two together, you get 0. Or if you want to use a number to sort of quantify those differences, you sort of square the differences between the observed and the average, that deviation, and that deviation, if you add it up, the sum of squares of the deviation, the variation, that gives you a number. And that central tendency is the least sum of squares, the line of the least sum of squares, which is the average. But in actual fact, that number might not be a representation of anybody in that sample. There might be nobody at that average number. And in fact, if there are outliers, that average number might be a pretty terrible predictor of height in that sample. And not only that, if you were to say anything more about heights within that sample, you can, but it might not be an accurate description. And if you want to say anything outside that sample, you probably can't, because you can only really make a comment about the sample you've got to a certain extent. If there's a relationship, let's say, between age and height, then that relationship might be linear in certain parts of the the age variable, but it might not be linear in other parts, or the actual difference, the relationship might be different. And outside those data points, it might not be linear at all. So there's limitations to the use of quantitative or methodology, obviously. Now, when you're dealing with qualitative, you're actually dealing with individual cases, a real case, not a central tendency, if you like. and that's got some attractiveness too. However, when you're dealing with that individual case, you've got to, somehow make measurements about that individual case too, and those measurements are only as good as your ruler. And I guess in quantitative work, you're using numbers to sort of quantify things, and in qualitative work, you're using well, what are you using? You're coding, but you sort of, if you code and sort of try and put them into numbers and then make assumptions, then that's sort of outside the qualitative methodology. And in the qualitative methodology, we're told you can't make assumption outside the actual little sample you're looking at. But that's not really true, is it? Because we do make assumptions and generalizations outside our sample all the time, and it's because of our experience in the past, because of our reading, because of our trial and error. These little heuristic shortcuts we make all the time, and that's because humans like that predictability. So it's very difficult to separate them into two separate camps, and you can on philosophical guidelines, I suppose, but in actual practice, I think the research it tends to blend, and we only separate it when we have to separate it because the assignment says we have to separate it, or we separate it to the extent that we don't understand those statistics. So we look at the qualitative work. Of course, in the qualitative work too, I mean, you're relying on observation or feedback from the respondents or the subjects, and that feedback could be a lie. It could be a lie they're telling us, a lie they're telling themselves, and then they're telling us. So there's a bit of grey area there too. Anyway, what I'm leading to, I suppose, is what most of you may have come to the conclusion yourself anyway, that there's a mixed methodology that's probably the best way to move forward, and you sort of mix and match as you go, but it's also an action research process too, because one informs the other, and then you keep on rolling forward with your inductive or deductive processes. Anyway, I'm going to finish up there now because I want to keep it short, and good luck with next assignment. Bye.